Is that the adding sign?
Yeah.
Yeah. I don't know how to work it out very well.
Did she
Or
even
like,
teach it?
yeah, she taught like the different equations. Like, oh, if you're using, you could always split it up into n minus something times this instead of like typing it in a calculator.
Yeah. But do you know how to do summation into infinite partitions?
No.
All right. This is the definition of sigma notation. And B and A are the A to B, the boundaries. So like you have a definite integral.
Mm-hmm.
It's the same thing. It's just boundaries. But this is sigma
Oh
notation.
yeah. That's where you rewrite the limit of the sigma notation into the antiderivative.
Yeah, but she didn't teach you how to solve like this. Now I need to know how to solve it like this.
Okay.
So y'all haven't even solved one like this, have you?
No, we've only done it with the antiderivatives.
Ugh! She skipped over it. I don't like how this college skips over it. Because I got to Calc 2 and I had to do this religiously for a little while. I think it's just my professor. All right. Delta x in this equation is b minus a over n.
Mm-hmm.
And xi, what this is right here,
Mm-hmm.
is a, this a plus delta x times I. I don't know if you can see that.
Yeah, I can see
That's
it.
delta x times I. You're going to need that. Because in the first problem, I didn't really show it, so. All right. Skip from that. Share. Oh, mixer. Whoops. I'll see who's streaming. All right, so this problem, solve this problem right here. Well, I'm just going to walk through this problem. Does that work for you, or do you want to solve that? Because I accidentally have it solved down there.
Um, you could walk me through one of those since I haven't really done it.
Oh, no, the definite integral. Well, I'll walk you through the definite
Oh, the
integral.
definite integral. Yeah, huh. That's where I write the antiderivative and replace like the a and b.
Yep. This right here, 0,
Mm-hmm.
comes here to the bottom. That's your left end. And 3, I wish I had different colors. Comes right there.
Okay.
So that's A. Ew, 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 ew. A, B. I cannot write A with a mouse for nothing. So there's your A and B, and this is your f of x, and then you just have dx. You have to
Okay.
have the dx because that's very important.
Really?
Yeah, it's the only way you can take a antiderivative,
Mm.
or integral. Anyway, so what's the antiderivative of x squared?
X 1/3 x to the power of 3.
Yep, right here is pretty much what I wrote. When you do that, you either put it in brackets or you do.
Yeah.
That shows that you're about to evaluate it from 0 to 3. You have to do either of those. Or it's considered incorrect work and they will dock off points. And I keep telling you they will dock off points because I've lived it. I've lost so many points. Anyways, so what do you do after you get this?
Plug in.
Yep. Or how do you plug it in? What
Uh,
is this? This you're supposed to. What does this mean? Like, remember,
are you
capital
supposed to
F
write?
is the antiderivative.
Are you supposed to write all the fill in the x's one by one type of thing, or?
All right. So little f when you do a big F, that means it's the antiderivative of little f, correct?
Mm-hmm.
Okay. So you do this, and then once you get this means you subtract the upper limit minus the lower limit. So f of 3. So this is 3 cubed divided by 3.
Okay.
Minus 0 cubed divided by 3, which is 0, and 27 divided by 3 is 9. Making sense or jogging your memory?
So it's the biggest value of like plugged in into the antiderivative minus the smallest value, or I guess
F
b
of
minus
b,
a.
f of b minus f of a, capital F,
Okay.
the antiderivative. That's all you got to do.
And that's instead of doing the sigma notation, right?
Yes. See, I did this in one line. I'm about to let you know the rest of the problem takes the rest of the page. Or the other way takes the whole page.
Uh, Doing it through sigma.
Yep. But you have to know how to do it through sigma, because when you're working out a problem in real life, you get it in sigma notation and then you realize, hey, I can turn this into an integral, and you're golden. So is all this clear though?
Okay. Doesn't the integral also find the area under the curve?
Yeah. Find the area under the curve with definite integral and sigma notation.
Oh, so basically x squared is the the graph, and then from point 0 to 3, and using integrals, that's where we find the area without doing the whole
The
split.
area between the line of the graph and the x-axis, yes.
So, and this is better than doing the before what you taught us about the
Approximations.
yeah.
Yeah. This is exact. The
Uh,
exact value.
Okay, so we're gonna have to be tested on midpoint left and right.
Yes, you're gonna have to know how to do that.
Okay.
It's approximation, so like when you can't integrate, you gotta be able to approximate like that, and that's the point of those.
Oh, okay.
All right. So, sigma notation. I write it down every single time. I forgot to write this down over here. Limit as n approaches infinity. Remember what I wrote down the other one? Is I equals 1. I used I instead of k. I equals 1 to n f of xi times delta x. Oh crap. Never mind this.
Okay.
Never mind that. And delta x equals 3 minus 0 over n. It's supposed to be a comma. And then it equals n. And xi equals a right there. So 0 plus delta x, which is this. Three over n times I. So 0. So it equals that.
Okay.
You following along?
Yeah, so far.
Okay. So now is when you just got to start plugging in. Never drop your limit till the very end. So you have your xi, right?
Mm-hmm.
So you take this, you plug it in right there.
Into
And you
the
plug in, yep, inside the equation, because f of xi.
Mm-hmm.
And you take this, you put it right there. You're just plugging in right now.
Okay.
And since f of x equals x squared,
You squared 3i.
yep, 3i over n squared.
Okay.
So when you square it, 3i over n squared equals, oh crap, I moved too fast. This right here,
Mm-hmm.
that equals 9i squared over
And squared.
n. Yeah. Why did I skip through that? I need to get better at that. Okay. So what you can do with this, you can pull out, you multiply these together, the 3n and the 9i squared over n squared, and you get 27i squared over n squared, or n cubed, because n squared times n equals n cubed. You following?
Yeah.
And then you pull it out of the sigma, since it only has to do with I. What you want to do is get it in terms of I first and bring all the n's on the outside if you can. But you can't take it outside of the limit because you have an n right there. You following?
Yeah.
All right. Do you remember the formula for I squared? And with a summation of I, or like I, or you had a constant, you have I, and you have I squared.
No. I think you told me to memorize it, but I haven't really memorized them all.
Yeah. Oh, I'm so tired of physics.
I spent 5 hours this morning trying to finish a programming. Couldn't do it, so I'm just gonna wait till tomorrow.
Oh, dude, I feel you. Like, tests suck. All right. There you go. So when you have k squared, it's n times n plus 1 times 2n plus 1 over 6. Always and forever.
Okay. That's like a simple way, right? Like fast way?
That is the only way. They're derived for you.
Okay.
They have a lot of these derived. You just can't really. They're really hard to do. I think they showed me one and I didn't even memorize it. But this is what, when you have I squared, when you just have I, it's that.
Okay.
But when you just have a constant, it's just n times the constant. So since we have I squared, we replace I squared with that, or summation. You replace this, turns into this. That whole equation. Yep. 27 over n cubed times this over 6. You following along?
Yeah. I'm just thinking how we're gonna put infinity into n.
You'll see.
Okay.
And so what you got to do, you got to FOIL this out. And it's always the same thing every time. I don't know why they don't give it to you just to already not factor it out, just put it normally. But you got to FOIL it out. So I distributed the n, and I swapped the 6 and the n cubed so you can simplify better. So you got to FOIL this out right here. And you end up with 27, limit is n approaches infinity of 27 over 6 times 2n cubed plus n squared plus 2n squared plus n, because I FOILed this out.
Okay.
And so you put those together, you get 3n squared, correct?
Uh-huh.
So further simplifying, you get limit as n approaches infinity of 27 over 6 times 2 plus 3 over n plus 1 over n squared. But when you plug in infinity to n, what do these approach?
0.
Yep.
Also, even infinity squared is also just the same thing as 0?
Yeah, because it's in the bottom.
Wait, where do I see where you got the 2, but where do you get the 3n?
3 over n?
Yeah.
Because these two right here, these two.
Mm-hmm.
And when you divide that by n cubed.
Oh, the 3 goes away? Or the n, okay.
The n squared goes away, and you get left with one n on the bottom, so it equals that.
Yeah, but in the thing it just says n squared.
What says n squared? Oh, no. You have n squared plus 2n squared.
Yeah, and you add them together.
Yeah, because I have the same.
I see why. Okay, I was confused why there was a 3.
Yeah, I forgot to show it. I think I was running out of space.
It's fine. I see it now.
And so you end up with 27 over 6 times 2, because these approach 0.
Mm-hmm.
So when you multiply those together,
That equals 9.
yep, this turns into 3, and 27 divided by 3 equals 9. You like definite integrals better, don't you?
Yeah, it's just one equation.
Yeah, that's what.
I mean, here's one equation too, but like it's a longer equation.
See, I did this. See how quick I did this,
Mm-hmm.
and then boom, the rest of
That
this.
one you have to FOIL out and rearrange twice.
Yeah. All right. I'm gonna let you try this one.
Mm-hmm.
Do the definite integral and then try sigma notation. You're the only person getting sigma notation.
It's the sigma. You said definite intervals don't always work.
It has to be continuous over the interval. But if the sigma notation doesn't work, the definite interval doesn't work. But
Okay.
you need to be able to approximate when you can't do the definite interval.
Yeah.
So that's why you need midpoint.
Housing for next semester is gonna be open next week.
What's going to be open?
Housing, room selection.
Oh, I already got mine.
You got yours?
I reserved my room.
How did you do it ahead?
Because if you're staying in an upperclassman area that they're not messing with over the summer, you can go ahead and reserve your same bed. Howell's freshman only.
Howells and freshmen only?
Howell is a freshman only dorm, so you can't stay there. But like
Oh,
if you stay anywhere else, you usually can reserve it.
oh, so like if I would have stayed in like comments, I could have reserved it.
Yep, HV2, I
Uh,
believe. Not
okay,
courtyard because they're kicking people out of there.
yeah, I'm gonna have to choose the I think comments or courtyard, whichever one's cheaper when they show it to me.
Uh, co-
Comments.
Commons is about 400 a month or 400 cheaper a semester for the 4 bedroom. It's $75 cheaper a semester for the 2 bedroom.
Mm.
I mean, I like it here. I only have to share a kitchen and a laundry room with one person and a living room.
Yeah, but I don't know what they're gonna have since it opens Monday, but my time ticket is Tuesday.
Ugh. You might want to start looking for housing around here.
Yeah. What the heck am I messing up here? I can't.
Did you get the definite integral yet?
Trying, but I got used to the other way.
Well, no, the definite integral with the S.
Yeah,
You
that's
got that
the
already?
no.
Huh.
For some reason, it's not coming to me how to write the equation.
That. You plug in your
Yeah,
bounds.
I remember x4. Yeah.
What's your first step?
Uh, Finding the antiderivative
Yep.
equation. Yeah, that's the part I got stuck on. I don't. I remember how to do something like x to the fifth, but not 5x.
You don't have x to the fifth. This is x to the first right here.
No, no, I get that, but I mean like how to move the 5 down there. Um,
You don't have to move the 5 down there.
okay, I think I got it. Is it 2.5x squared minus 2x?
Yeah, it's antiderivative. Now you have to plug in your upper and lower bounds.
So that would be 2.5 times 4 squared minus 2 times 4 minus 2.5 minus 2. Okay. Oh, was I in your session last Friday?
No, I forgot to tell you I came back from the funeral.
Mm.
So it was a no-show, and I was like, why doesn't Andy shut up? He usually jumps at the opportunity for free homework help. And I was like, oh yeah, I thought I was going to the funeral.
Yeah.
Everybody kind of
Is it?
hurried away because of the illness, and my aunt, she got tested for it that day. It came
Ooh.
back negative though.
Okay.
She works at an elementary school, so did you know that the deaths for the coronavirus are not that high as what the media says?
2%, and like
No,
something else for like elderly.
no, it's 2% for the entire population. It's 0.2% for people our age. No, flu deaths have went to zero since the pandemic started in the U.S. So doctors, if there's any type of symptoms that resemble the flu and or the coronavirus, they just put it under the coronavirus. So our usual flu deaths are the same as the coronavirus, or being jumbled in with the coronavirus now.
Uh,
Uh-huh. All right, did you get the antiderivative?
yeah, 31. The antiderivative is 2.5 x squared minus 2x, but is it 31 1/2 or
Yep.
31.5?
Yeah, that's 63/2.
Okay.
Now try sigma notation. I even give you delta x.
Oh, you gave me delta x. That's 3n squared. Okay.
It's just 3/n.
Do I have to plug that in for the x?
For delta x, yeah, that's pretty much dx, but this is you have to find xi too. Don't forget. What is xi? Oh, there it is.
Hmm?
You got to find xi as well before you can start this problem.
Oh, right.
Xi is a plus delta x times I.
What's a?
From a to b.
Oh, yeah. Okay. That would be, yeah, 1 plus. Why is it written limit as n approaches infinity, even though it's only from 4 to, or 1 to 4? Why is it written as n equals infinity, even though it's only from 1 to 4?
N is the number of partitions.
Oh. Okay. That's 1 plus 3. Yeah, I got lost.
You don't want to keep trying? All right. So what's the first step when you find delta x and xi?
Okay.
What's your first step after you find those? Do you remember what you do?
Yeah, you just
Plug it in.
find the change, yeah.
Plug it in. So you get 5 times 1. This is x, right? You get 5 times 1 plus 3 over n minus 2. I forgot the minus 2 at first, and I had to redo a bunch of it. Times 3 over n. You think you can pick up from right here?
3 over n, doesn't that just become 0?
No. You can't do it yet. You have to
Okay.
get rid of this first.
What, the limit thing?
Yeah. The summation. You got to get rid of the summation first. Get rid of him.
Do I just ignore it? Do I have to move something?
You have to simplify this first. So you get 5 plus 3 over n minus 2 times 3 over n. Remember?
5 plus 15 I over n. Yeah.
Minus 2 times 3 over n. So you simplify it, and you can cancel out these two, and you get a 3 plus 15 over n.
Wait, which one's cancelled out?
Oh, when you add these two, you get 3.
Oh, yeah.
And so when you do that, you get 9 over n plus 45 I over n squared. And then when you come up here, you see that sigma can be distributed to both of these, right? Plus or minus. That's important. Once I get here, like after this, you got it. I'm gonna let you finish it. But you get 9 over n because you multiplied by delta x, right? Once you simplify that, so 3 times 3 over n equals 9 over n, and 15i over n times 3 over n is equal to 45i over n squared. So you distribute the sigma and the limit. You can distribute the limit, but you don't need to. I think I did it just to show that we could. So you distribute these into each of them, and you solve each of them separately.
It doesn't the 9 over n just become 0?
No. Right here, you need this rule, the constant value rule, rule number 4.
Oh, so
Pull out the 1. Yeah, pull out the 1 over n, and it would be sigma of I. It would be sigma of I equals 1 to n of 9. All this, you pull out the n. I'll try to write it to there. And over here, you pull out the 45 over n squared, just so you can get I by itself. Again, she uses k, but I don't like k.
1 over n limit of n to the infinite.
Keep the limit, keep the 1 over n inside the limit.
Keep the which one? 1 over n.
Keep it. You can't take it outside the limit, or otherwise it doesn't have a purpose. It's just going to stay 1 over n.
So it becomes 1 over n. Is it plus 9 or times 9?
See, I took the limit back out, so you get 1 over n times summation of I to the n, or I equals 1 to n, right?
Mm-hmm.
And I pulled out the 45 over n squared right here.
Okay.
You remember the formula for I? All right, hang on. Let's start off with this one. This rule, get rule number 4. So this turns into 9 times n, right?
Mm-hmm.
This whole thing turns into
the
constant multiple rule, 9 times n, right?
Mm-hmm. So you changed it into that?
Yeah, you turn this whole thing turns into the 9 times n. Yes.
Okay.
And then I, which is just k, is n times n plus 1 over 2. So this right here.
Mm-hmm.
So we move.
Wouldn't the 1 over n times 9n, doesn't the n's cancel out?
Yes. Eventually you're getting ahead of me. So we end up with this. And now you're just solving a limit. So I'm going to let you try to finish that up. Now you just simplify. If I'm not mistaken, I only have one more example. But I'm glad I do because these problems take a while, don't they?
see.
Do you miss the college's good internet?
Yeah, I've been dealing with 0.4 megabits per second.
That's disgusting.
It is.
I hooked up my Roku in the living room, and I have a giant 50-inch TV in my room.
Mm-hmm.
But I hooked up the Roku in the living room. I've been watching TV and Netflix and stuff in there instead of my room, and I don't know why. It just feels like simpler times being in the couch.
I got it simplified to 9 plus 45 over n squared times n squared plus n over 2.
Yeah.
And then does the n squared cancel out?
Well, pull the 2 out and to the n, and you have n squared over n squared plus 1 over n. So you have 9 because the n's cancel out right here, and you get 45 over 2. You have n squared plus n over n squared, right?
Wait,
You can separate this into n squared over n squared plus n over n squared. Correct?
oh, okay, I see. Okay, yeah. So you switch the n squared into 2 places?
Yep. Why did I write alpha? What on earth was I thinking? Yeah, I switched. You can do that because they're multiplied. You can swap these.
So, oh, you could swap the denominators?
Yeah, because they're multiplied, remember?
Okay.
So why did I write alpha? That's such a pretty alpha, too. Like, what was I thinking? Anyways, so you end up with 9 plus 45 over 2 times 1 over... Oh.
Infinity.
Apparently, I just can't write.
That just the 1/2 cancels out, or does it become 0?
Becomes 0. Ugly. That becomes 0. So you end up with 9 plus 45 over 2. But 9 over 2 is 18, or 9 is 18 over 2. So you add those two together and you end up with 63 over 2.
Wait, how come? Oh, okay, I got it.
You're multiplying. Don't forget you're multiplying these two. You're not adding them. So since that's just 1, you're just multiplying it.
Yeah.
All right. You need any clarification of
That's why
anything?
the 9 became 18, but yeah, I remember.
You're breaking up real bad, so I don't know if your internet can handle it, but
Yeah, we'll see.
yeah. All right. One more. No, I
Wait,
have 2 more. Oh,
2 more?
crap. Yeah. I came up with this one off the top of my head. So you know what that means. It's going to be fun.
Yep.
All right, do the definite integral first and then sigma notation.
Okay.
Remember, my notes are going to be published later. And there's going to be a video on YouTube because I hadn't put one up in a while.
So this is that equals 4 or minus 4?
It's minus. I don't know what those little specks are. They're probably eraser dust. Do you know what apple cider vinegar is?
Apple cider vinegar. No.
It's disgusting, but like it curbs your appetite. And I'm having to shrink my appetite, so I drink a little bit of that, and I don't eat all day. Like I had a sandwich, and I felt like I was about to bust. All right, I'll let you work on this real quick and stop bugging you.
Oops.
Did you get the definite integral yet?
Yeah, I got the definite integral or the equation.
Oh yeah.
What the heck?
Yeah.
41.
So you get execute. This is your antiderivative, right?
Yep.
So you plug everything in. The right
Yeah.
hand side turns to 0, so you don't have to worry about that.
Over 6. Yeah, that was a big fraction I had to.
Yeah. All right.
Yeah. Yeah, 655 over 6. Not a long way.
Yeah.
Okay.
Sigma notation. Let's see if you can do it now.
Limit of n to infinity of I equals 1 and what is it, x squared?
No, it's it's x squared plus 7x minus 4.
Times the change of x. And the change of x is
dx or delta x.
yeah, delta x, that's
Delta x equals b minus a, so 5 minus 0 over n.
just 5 over n.
Yep. And xi equals a. Lucky for you, it's 0 plus delta x times I, so it equals 5i over n. You there?
Oh, yeah, I'm here. So that's
Just
when I plug it into f of 5i over n, that becomes 5i over n squared plus 7 5i over n minus 4.
Yep.
Now
Times
limit n to infinity times
delta x.
5.
Yep. Don't forget.
It's 5i over n.
Nope, just 5 over n.
It's 5 over n, yeah. Okay.
And now you simplify. You square
I
everything.
Wait, I simplify?
Well, you square everything. Yeah, you square everything, and you can't really simplify too much yet. But square everything and bring it all into one equation. So what's 5i over n quantity squared?
25i squared over n squared?
Yep. And 7 times 5i over n, what's that?
Oh, that's 35i over 7n?
No. Just n.
Over n,
That's
okay.
just 7. And then 4 times 1 is just 4. And then you multiply everything by 5 over n. That's what I meant by simplify. So
Okay,
you
so
got
that
this
would
right here.
be. Do the denominators multiply times each other?
Yep. So 5 over n times 25i squared over n squared equals 125i squared over n cubed. In fractions, you just multiply across the top and bottom.
Yeah. Plus 175i over n squared minus 20 over n.
Yep. Booyah. And now what do you do?
Can I pull out one of the ends?
Well, yeah, but what do you do with this guy first?
All right. Let's see. I separate each one. Yeah.
Yep.
The limit of one plus the limit of the other.
Or you don't have to do the limit. You just distribute the sigma first. And I went ahead and pulled out the constant and the n too. because I was trying to save space. You can get you can get an idea of like I was getting aggravated at this point. What the hell slapping my handwriting was. In high school, I had to do this for 2 weeks straight. So I pulled out the 125 over n cubed and distributed the sigma. So you just have I squared.
Why did it become that 2C?
That's I squared. Oh, no. 20.
Okay. So, okay, so I have to make I by itself when I have to separate the. Okay, that I was getting confused with that. Okay, I get it now.
You need I by itself, so you can use these equations right here to get it in terms of n, so you can solve the limit. You need to get rid of the I first, and then get rid of the n with the limit, and then you have an answer.
So then the I squared becomes. Oh, I know I isn't I n times n minus 1 over 2?
N times n plus 1. Imagine the I or k is I right here. You need these two formulas right here.
Yeah.
I'll let you write those down from that.
Where's that?
You much prefer the definite integral.
Oh yeah. I don't remember which ones of this I have to memorize still though, but I can always double check my answers with definite integral. Or if it works, I guess.
Well, yeah, you can always check your answers with definite integrals. Yeah. But if I were you, I'd just like have these written down on a sticky note. This was the only notes I was allowed to have on a test were these right here in high school. I had 4 years of high school math with the same teacher. She gave us a sticky note, and I was allowed to have these equations.
That's odd.
Yeah. But what are you going to do?
I never took calculus high school. The other classes I had were the other classes like algebra and geometry aren't taught in high school.
Oh yeah. All right, did you get those equations?
Okay. Yeah.
Did you get them simplified? Actually, you can always, because that'll always equal this. I squared and I will always equal that. So if you want to go ahead and like write in a little sticky note that they're simplified or they're foiled out forms, you can do that. So now you have this beautiful long equation because you replaced the sigma I squared with that and the sigma I with that and the sigma 20 with this over here. So you think you can solve it from here? Now it's just algebra and a limit.
I switched the denominators.
Yeah, you can switch these denominators, but not in between these signs right here.
Yeah. So 125 over 6, 2n cubed plus n squared plus n over n cubed. I have to simplify that even further. Plus 125 squared 1 plus 1. And then just, let's see. That is 20 minus 20.
Yep.
And then that's 125 over 6.
That turns into 125.
2 plus 3 over n plus 1 over n squared.
Yeah.
And then I'll cross out the n's. Plus 170 times 1, so that's 175 over 2. Minus 20. 75 more. 125 times 2, that's 250 over 6 plus 170. 5 over 2 minus 20. That's, I'm guessing the same thing.
Yeah.
655 over 2?
Yeah, or over 6.
Over 6, sorry.
Yeah.
Yeah, because I have to get 175 to equal over 6, and then that, yeah.
Well, this will be 250 over 6, and you multiply this by 3 over 3. You get something. You multiply this by 6 over 6, but it gives you this answer. I plugged in the calculator.
Yeah.
All right. Now, the coup de grace.
You should see, yeah, my notes for the definite integrals like only goes down to like 3 different equations, and then the limit one it goes down to like 10.
Yep.
Okay.
Keep in mind, I did all these yesterday. It took me an hour to get to find the problems and work them out from scratch and everything. Because I had to review everything too to make sure I was teaching it to y'all right. So, all right, just do the definite integral, and I'll walk you through the other one, unless you want to do the other one.
Yeah, I should. Yeah, I'll see if I can do it. If not, then I'll tell you.
Yeah, you're gonna need this one right here. The first step, you find. Yeah, I'm gonna let you. Yeah.
It's x over 4. Oh, yikes. Okay.
It's not that bad. If
Yeah,
you want.
it's let's see what 20. It's like 390,000 over 4. How did you simplify it?
It'd be 1/4 x to the 4th, right?
Yeah.
0 to 5. So you get 1/4 x to the, or 5 to the 4th is 625.
Oh, it's 5. I was writing 25. Okay. Because it wasn't working.
You think I would make you do 20? Oh my god, dude.
I was like, why is it 300,000?
Yeah, it's just 625 over 4.
Okay. Yeah, that one's bad.
All right. Now, I'm gonna let you solve it. You want to try to solve it real quick, or I'll butt in at 725. I'll be right back there. I gotta get some water.
Okay.
Actually, I'm gonna give you control. How do I give you control? Yeah, how do I give you control over everything? You should request control and see what pops up.
Oh yeah, request control.
There you go.
Oh, there we go. I see
control.
my mouse.
Yeah, I'll be right back.
Okay. Oh. Okay.
You going strong so far?
Yeah.
See, it's not that bad. You got to the point where you need I cubed yet?
Yeah, I forgot what the I to the third equation is. That equals. That's cubed plus n squared over 4. Is that what that simplifies to?
Do what?
Does the n times n plus 1 over 2 squared equals to the 1 over, or n to the third? What the heck?
N squared times n plus 1 squared. You can simplify it to that. And over 4.
Mm-hmm.
Then you can pull out or swap the n and the 4. And then when you do the n plus 1, you get n plus 1 squared, quantity squared. So when you get n plus 1, you get n squared plus 2n. Why did I draw like that? Plus 1. That's what n plus 1 squared equals, right?
Mm-hmm.
And so you distribute the n squared, turns into this. Because when you have a square like that, you can square everything in there as long as it's all multiplied together.
Wait, so it's okay.
So that equals n squared times n plus 1 quantity squared all over 4. This is 2 squared down here. And so when you have that, I'm sure you know what to do. I'm sure what's annoying is having to solve all this when you see the correct answer right here.
Yeah, but I know that's 1 and then plus cancel out, cancel out, cancel out. What about the 5 over n? Where did that go?
What 5 over n? Delta x?
Yeah.
Right here.
Oh, you distribute. Okay, that's where why it got weird.
Yep.
Okay. Cancel out, so that's just 625 over 4.
Yep.
Okay. I wonder what she's gonna teach though.
She probably won't teach this if I recall correctly. My other classes.
Mm.
So, all right. So, any more general question? Oh, you still got control.
Oh, okay. Let me. I could stop it. There you go.
No, I didn't care. So, any more general questions about all this?
Not really. The homework so far is super easy. It's just like writing or changing definite integral or limit to definite integrals, vice versa, or what happens if you had a times 3 or something like that.
Okay, so it's not
No,
hard
or
at
like
all.
no. If the symbol's reversed, then it just becomes negative, right? Like instead of 1 to the fourth, and it's instead of 1 to 4, and it goes from 4 to 1, it's just negative, right?
Yeah. Well, I cannot draw with a mouse. I really wish
And you got really
my
good.
tablet worked. It's probably better than my in-person handwriting.
Yeah.
Yeah, that's it. That's the rule. So it's not hard to remember that.
Mm.
So
So unless you teach us something weird tomorrow, so far it seems good. Just practice and that's it.
tomorrow,
Yeah.
I
So
bet
that's
she's gonna
cool.
do like trig derivative or integrals and like harder integrals. Because
Oh.
5.3 is nothing but harder integrals. This is the basic of the basic, and this is the when you want to know the definition of an integral,
Hmm.
that's the definition of integral.
Mm.
This. So
Yeah.
that is the definition of an integral.
Trig. I forget about trig. Trig is always so. It's not hard just doing trig by itself, but calc trig is really weird.
It's yep. Pre-cal is just memorizing everything, but you don't know what to use it for. And in calculus, you start using it for stuff, and it's just annoying because you have to memorize it all again because you thought you'd never use it.
Well, I never knew it before, so.
Oh yeah. Well, they beat it into me in high school.
Yeah. No, I thought I could skip it. Or I did skip it, but it came back to bite me.
Yeah. In high school, I did dual enrollment, so I did advanced algebra or college algebra because I had to get the credit for high school or something, and then I did pre-cal.
Hmm.
College pre-cal was no joke. That class was hard, especially when you're in high school and I'm working 30 hours a week and going to class. Well, yeah, that sucked. Anyways,
Yeah, I used to do that, but then as time kept going forward near graduation, I just worked 1 day a week.
no, I wanted money,
Yeah,
so I kept saving up money.
it kept going down. I used to do 40 hours a week, and then it just kept gradually slowing down to just one day.
I mean, yeah, I wish I could did that sometimes, but then I was like, what else would I have done? I was in a small town.
Mm.
All right, dude. I'll let you get to your project for programming.
Yeah, they're doing a night session, but I hope to actually talk about what I have to do.
Oh, it's another SI session.
No, it's my teacher.
Oh,
They do like night study sessions or early morning ones, none of which I can attend usually.
oh wow,
They don't do
that's
classes, period. They stopped doing all classes. If you need help, you need to like book an appointment.